We are live at the Palace. Here we go. Chapter 2, Linear and Quadratic Functions. Again, my favorite section of Chapter 2. We're going to be talking about parabolas, okay? And I love parabolas. Does anybody know, when you think about a parabola, what kind of curve are we thinking of? Yeah. How many of you know what we're talking about when we talk about a parabola? Okay? Yeah. You should know it's a what? A U. Ready? Everybody get it. X squared, a parabola is a what? A U. Ready? U! Soldier boy. Okay, so you just got to remember, every time we deal with a parabola, we're dealing with a what? U! Okay, so that's what we're going to be talking about in this section. Parabolas, U-shaped curves. Okay, we're going to be talking about how to find its vertex, indicating key points such as intercepts. And intercepts, we're going to be really focused in on x-intercepts, which we call zeros. Everybody, what do we call x-intercepts again? Zeros. And the vertex, which is going to either be the min or the max of the parabola. Okay, the vertex is either going to be the min or the max of the parabola. Okay, and Gabe, you weren't here Friday either. I do have the video from Friday. Okay, for you and Wingnut over here, and then other Wingnut. Okay, that was referring to you, Greta, as you watch this. All right, so we got Wingnut 1, Wingnut 2, Wingnut 3. All right, analyze the quadratic function in general and standard forms. We'll talk about that. And then quadratic formulas, using the quadratic formulas. I'll teach you a song for that. And then using the discriminant to identify kinds of solutions, which is, the discriminant is a certain part of the quadratic formula. It's the part under the square root, if you already remember the quadratic formula. All right, here we go. Quadratic formula is a function of the form f of x equals ax squared plus bx plus c. Okay, quadratic function is of the form ax squared plus bx plus c. This is different from a linear function, which was mx plus b. A line was just mx plus b. This is similar, except for there's an extra term. There's the x squared term, and I'm going to label these. The x squared term, this is called the quadratic term. Like if you don't have an x squared term, you can't have a parabola. And if you don't have a parabola, you don't have a U. Okay? So in order to have a U-shaped curve, you need to have an x squared term. An x squared term lets you know you have a parabola, and then we have a U. Okay? All right? So we're going to get x squared. What is the x term called? You dealt with it last chapter. Or in section 1. Section 1. It's the linear term. It has a slope. Okay? This is the linear term. Sorry, 2.1. You guys said was the easy section. Linear term.
No, 2.2 is the easiest section.
The absolute value section was easiest. Okay? So we have the quadratic term. We have the linear term. So this doesn't have a slope of m, but it has a slope of what? What would you call the slope here? B. Okay, usually we do mx plus b, and b is the y-intercept, and m is the slope. But here, they're letting b be the slope. Okay, because the coefficient of x is always the slope. But if you have an x squared term, it's not a linear function. It's a what? It's a parabola. Okay? All right?
I think Greta will be able to do that.
Yeah, she will. Yeah.
Hey, what is it, Carter?
It's right here. My mic's right here.
Oh, never mind. I thought you were recording on it.
All right, so then we've got ax squared plus bx plus c. What's c?
The y-intercept.
That's the y. That's going to be that's a lot of things, and that's actually good you knew that. It's the constant term, which happens to be the y-intercept. Now, what if I only had a constant? What if I had no quadratic term, no linear term, and I only had a constant? What would you have then? You would have a horizontal line. If you have y equals a number, you have a horizontal line. So if I start with just, everybody look up here. If I cover these two up, what do we got? If I just have a constant, what do we got?
A straight line.
A horizontal straight line. But if I give it bx plus c, now it's not a horizontal line. It's a line with either a positive slope or a negative slope. And then if I don't cover up the x squared, then we're talking about a what? Yeah, we're talking about a parabola, okay? So then we'll be talking about U-shaped curves, okay? All right, we'll cue it up. Now, A, B, and C are real numbers. They can be any numbers. They're the coefficients. Everybody, what do we call the numbers in front of x squared, x, and the constant. What do we call them? Coefficients. Now, c is its own coefficient. So a constant, it's its own coefficient because there's no variable. Okay, the domain of a quadratic function of any parabola is going to be double bar r, because we know parabolas, they either look like this, they open up and they go to the left and right forever, or they open down and they go to the left and right forever still. Now the range is not going to be all real numbers. What is the range going to be based on? What do we call it? It's going to be based on the vertex. How low that graph goes, which is going to be the lowest y value, which is what Addie said over here. It's going to be based on the y value. It's either going to be the lowest y value, which is going to be based on the vertex, or the highest y value based on the vertex. Okay? So, the most basic quadratic function, the parent graph for the quadratic function is x squared. It has a one-to-one relationship. So if you notice, x squared, if you plug in, let's just plug in a couple of points here. You don't have to write the table. You can just watch. What page is this on?
188.
I don't know why I put 0 there. I meant to put x. But if I start plugging in points, 0, if I plug 0 into x squared, 0 squared is 0. And then what you will notice with the parabola, with the U-shaped curve, the reason it looks like it looks, okay, if you notice a parabola has symmetry to it, okay, the left half is equal to the right half. Do you see the symmetry?
Yeah.
That's because when you plug in points on either side of the vertex, if you are equal distance from the vertex, you will notice that whatever you plug in, remember, an even function, a parabola is an even function. If you plug negative x in, you're going to get f of x. I'll review that in just a second.
So you're
Watch this.
basically doing like,
So,
you're
yeah.
basically doing the absolute value.
It acts like an absolute value. I didn't mention that when we did absolute value, but an absolute value is also an even function. When you plug in x or negative x, you get f of x. Doesn't matter if you have x or negative x, you get f of x. Watch. When I plug in 1, what's 1 squared? 1. Because it's always going to become positive. It's like the absolute value. If I plug negative 1, what are you going to get? 1. So this is an even function. Remember, an even function was symmetric to what? Let's go back to chapter 1. Symmetric to what?
The y.
Y-axis. Can't be x-axis because it's not a function. Symmetric to y-axis. And what was the rule for an even function? If you plug in negative x, you will get what? F of x. And that's what we're seeing here. We're seeing that if I plug in 1 or negative 1, we're always going to get 1. So now you see the symmetry. See it? It's wrapped around that vertex. And same thing if I plug in 2 or negative 2. If I plug in 2, I'm going to get what? 4. And if I plug in negative 2, I'm going to get 4. Do you see it? Okay. Let's make sure my wife's got her appointment figured out. All right. So then that's going to give you 4 no matter what. And if you go to 3 and negative 3, you're going to get 9 for both. So you've got this symmetry that's wrapped around the vertex. So here's my vertex. And the vertex is either the lowest or highest point of the parabola. Now, there's a one-to-one relationship since this is the parent graph, because you're going to do some transformations again, shifting left, right, up, or down with the parent graph. Notice it's a one-to-one relationship. So the vertical stretch or horizontal stretch or shrink, it starts out 1-to-1. So to get your first point, all you have to do is go up 1, right 1, up 1, left 1. And then the next point, you'd have to go up 1, right 3, up 1, left 3. And that's because a parabola, actually, it doesn't go up by the same amount every time. But there's what's called a second common difference. So the second common difference is this. It has a pattern. It goes up 1, then up 3, then up 5, then up 7. It goes up by every odd number. And then the second common difference is that's going up by 2 every time. 1, 3, 5, 7. You don't have to know that, but if you ever wanted to know how the parabola is increasing, there's a pattern to it. It goes up 1, 3, 5, 7, 9, 11, and then so forth. Okay, that's how squaring works. Squares are always separated. Think about your perfect squares. 1, 4, 9, 16, 25. Did you ever know this? What's the next perfect square?
36.
It has to go up by 11. Do you see their difference by odd numbers? If you've never seen that before. So that's what perfect squares do. So that's why the parabola goes, welcome back. You got to watch the first part of this video.
Yeah, it's pretty good.
That video?
Yeah, this one.
What's going on?
We're actually, I don't know how many minutes in. Probably about 10 minutes in. You got to go back and watch the first 10 minutes to this point when you walk in the room, because I do some shout outs to you. Okay? And I do have Friday's video. I forgot to send it out. And it's not very long. It's only like 25 minutes long. All right. So this is a parabola, a U-shaped curve. And the vertex, again, is going to be the most important part of this. So that's going to lead us into knowing the graph of f of x equals x squared, the parent graph for the parabola, okay, enables us to graph the entire family of quadratic functions using transformations. So we've got this parent graph, okay. Does that make the most sense, or would it make most sense to be the other way? What do you think works better? That works good? Okay. Because we can do whatever. I can make Gabe move. All right. So Gabe don't mind. F of x equals x squared. And we're going to use transformations to do this, just like we did the absolute value from last section. So when you got things inside the house. Now, with the absolute value function, the house was inside the absolute value bars. What's going to be inside the house for x squared? What's going to be inside the house for x squared? You'll have to be inside the square. Okay, the squared part, think of it as like a chimney on a house. Okay, absolute values, it was easier because you had the absolute values around it. So here there's understood parentheses around x squared. It's x squared. So there's these understood parentheses around the x. Now there is nothing inside the house right now. It's an empty house. And there's nothing outside the house. So we don't have, the house is completely vacant and nobody's looking at the house from the outside, creeping on it. Okay, Brody? So, examples. Let's go through some examples. What page are we on for the examples of the parabola? What page? 188. Now, how do I know that this is a parabola and not an absolute value flying V from section 2.2? Because a flying V has absolute values. Every time you saw absolute values, we knew it's a flying V. How do you know this is a parabola? Because it's going to be x squared. Now, some of you are like, wait a minute, there's no x squared here. Oh, yeah, there is. Okay, right now it's not in what you call standard form. It's what you call vertex form. Okay, and vertex form is when you can look at and tell if it's shifting left, right, up, or down. Does everybody understand if I was to take x plus 2 squared and FOIL that, would I get an x squared?
Yeah.
Does everybody understand if I took x minus 3 squared over here and FOILed it, would I get an x squared? So does everybody agree that this is a quadratic function? And all quadratic functions are what, everybody? They're all U's. Okay, so because I have, even though it's a house squared, if I FOIL out that house, I would get an x squared, agreed? Now, we don't want to do that because we want to be able to say what it's doing. So is there something inside the house? Let's review again. If it's inside the house, does it go left, right, up, or down? Left and right when it's inside the house. And remember, no means yes, yes means no. So if it's plus, we actually go to the what? This means left 2. What does the minus 3 outside the house mean?
Down 3.
Down 3. Okay, did you get a little message for your surgery?
Yeah, I did.
Okay.
Video that house.
Huh?
The video that house.
Yeah. Left 3 down, left 2 down 3. Now, is there any flipping that happens? Is there any negative on the outside or negative on the inside that would flip it? No. Now, I'm going to go ahead and talk about the flip now. One type of flip will affect it, one type will not. All right, since the parabola is symmetric to the y-axis, which flip is not going to do anything? The flip inside the house or flip outside the house?
Inside?
Outside the house will flip it upside down.
Inside.
Inside flips it over the y-axis, which means it really doesn't do anything because it's symmetric to the y-axis. Because remember, it's an even function. So f of negative x, if you have the negative on the inside, does that do anything? When you have an even function, the flip on the inside does nothing. Doesn't affect it. It's only the flip outside the house that affects it. So when I put the negative all the way out in front of it, that'll make it an upside down parabola. So we won't have a regular U, we'll have a upside down U. Okay? All right, so we'll get an upside down U. All right, so this goes left too. So here's what we're going to do. We're going to graph this. We're going to state the vertex, state its domain and range, state its x and y intercept. So you're going to do a real quick sketch. Just doesn't have to be perfect. Okay, so we're going to make it, and I'm going to show you how to sketch these because it's easy. And this will help you with 2.3, your My Open Math. So what does it do, everybody? Left 2, down 3. So everybody go left 2. It's just like the absolute value curve in the last section. Left 2, down 3. Did it flip?
No.
Is there a stretch or a shrink inside or outside the house? So it's 1 to 1 then. So we know it's going to go up 1, right 1, up 1, left 1. And you only have to give me 3 points. Now, let's give everything that you're required to give on this, okay? So, first thing you have to tell me is the vertex. Okay, what is the vertex? Well, you went left 2, down 3, so can you locate the vertex? Yeah, it will be -2, left 2, down 3, -3. Does everybody see how I got that? The vertex will be -2, -3. I went left 2, down 3. Can everybody plot that point and name it? All right? I would actually tell me the direction of opening too. Now the direction of opening is based on the value of A, which is your vertical stretch. Since A is positive, since A is a +1, which way does it open, up or down? Parabola opens up, opens up. Let's just get that out of the way. That's too easy. They actually we talk more about this later in the chapter, but might as well cover it right now. It's so easy to do. All right, what else do they want? Domain and range. Let's do domain. What's the domain for all parabolas? Okay, you weren't here for this, Greta, but this thing will go to the left and right forever. I know it looks like it's going straight up and down, but remember that day Brody asked me, is this thing going to keep going to the right? And I kept drawing up. Okay, this thing's going to keep going which way?
Okay, yep, we're good.
Can I keep going? I just want to make sure. Do you know that that thing's going to the right forever? Is that thing going to keep sliding to the right? Okay. Is it going to keep sliding to the left forever? Yes. So domain's definitely double bar R. For every U-shaped curve, the domain will be double bar R. What about the range?
-3 to infinity.
Yep, -3 to infinity. The lowest it goes, and that'll be based on the Y value for the range, which is what Addie said earlier. So it's going to be Y greater than or equal to -3 if you don't want to use interval notation. So Y greater than or equal to -3. Is that okay? All right. So domain's all real numbers, range. Now, the x and y intercepts. One of these is going to be easy. One of them is going to be tricky. Okay. X intercepts we'll deal with last because that's the one you're going to have to do work for, which are the zeros. Did your thing,
Yeah.
Fritz, on? Tell your dad to buy you a new one.
I just bought this myself, like, not that long ago.
You know what you should do? Back it up, uninstall Notability, and reinstall it.
I have this on files, like, so I can just edit it straight from there.
Oh, you should use Notability.
Yeah, but I don't want to pay for that.
No, your dad won't for you. Okay.
I don't know about that.
Yeah, he might not. All right, x-intercept, y-intercept. All right, what is an x-intercept? Where it crosses the x-axis. Can you tell where it crosses the x-axis, or would you be at best guess eyeballing it? You'd have to eyeball it and be like, I think, I don't know. You might even have drawn this incorrectly, and it might actually cross it what? Does everybody agree that we didn't draw this perfect, probably?
Yeah.
Okay, so at best we could eyeball it and say maybe it's, I don't know, -0.2, but I don't know for sure. So what I'm going to have to do to get the x-intercepts. Oh, that's awesome. Thank you. So at best, I'm just going to have to eyeball it. So here's what I can do for x-intercepts. Since it crosses the x-axis, what do I let equal 0? What do I let equal 0? And you're going to have to memorize this. We talked about it in chapter 1. We let y equal 0. For y-intercept, what do you let equal 0? X equals 0. So you're going to have to memorize that. So here we go. So I'm going to let, our y is g of x. I'm going to let g of x equal 0. So I'm going to have 0 equals, here, wait, I have to write this down. 0 equals x plus 2 quantity squared minus 3. Now, this one's nice. It does have a squared. It does have a squared. If you FOILed that out, it would have a squared and an x. So some of you are like, should I FOIL this out, factor it, set it equal to 0 and solve that way? No, there's an easy way you can do it when it's in this form. When it's set up like this and you have this quantity squared, you can solve by square roots. Because really you only have one like term right now. Because you don't have it FOILed out, so you don't have an x squared and an x. You just have an x. Does everybody see that? So because I just have an x, because I don't have it FOILed out, you can just add 3 to both sides and take the square to both sides. Do it that way. That's the easiest way to do this. So I'm going to add 3 to both sides. I'll show all the work so you can see it. So if you go back and look, you know what we did. So we're going to have 3 equals x plus 2 squared. Now what do? To get rid of the squared, you take the square to both sides. Now, when you take the square to both sides, remember it's an absolute value. It's piecewise. So it's plus or minus. Equals x plus 2, because that'll cancel that squared. And remember, it actually leaves you with the absolute value of x, but we go ahead and just make the plus or minus. And then we subtract 2 from both sides. So our zeros are going to be negative 2 plus or minus root 3. Yep, I don't think you're eyeballing those. Now, Addie already came and asked me about this on the My Open Math. Because it says, sometimes it says list the x-intercepts. So then you can just write negative 2 plus root 3. So you can write negative 2 plus root 3 and then comma negative 2 minus root 3 on the My Open Math. Sometimes it says list them as points. And it says, if it says list as points, you're going to have to write negative 2 plus root 3 comma 0 comma negative 2 minus root 3 comma 0. So if it just has an x equal on the My Open Math, you can do like this. But if it says list them as points, you got to write them as actual ordered pairs with the 0 for y. Okay? Y-intercept's a little easier. And here's the thing that I need to talk about, though. The y-intercept's definitely easier. But earlier on, Aubrey said the y-intercept is the constant. She was right. Go back up to where we started. Ax squared plus bx plus c. This is the first thing we started with. X squared is the quadratic term. Bx is the linear term. C is the constant. Constant's always the y-intercept. But you notice that is only when this is multiplied out. So the constant is only the y-intercept when it's all FOILed out. Is our problem FOILed out?
No.
No. Then you don't have a choice. Because it's not FOILed, the y-intercept is not necessarily negative 3. You're going to actually have to plug 0 in for x. So you're going to have to plug 0 in. So it's going to be, ready? It's going to be f of 0, or g of 0. Is it g of x? Are they using g?
Yeah.
So g of 0 would be 0 plus 2 squared minus 3. And and it's easy to figure out. What's 0 plus 2? What's 2 squared? What's 4 minus 3? So the answer is 1. That's the y-intercept. Okay, not hard. A little bit of work, but not hard. Okay, you guys walk me through the next one. Any questions so far? Okay, walk me through the next one. What happens on this graph? Remember, we're doing the test Thursday, not Wednesday now. This one goes right 3.
Are you ready for that, buddy?
What else? Up 1. Does everybody agree? Okay, because we got inside the house goes left or right. We got outside the house goes up or down. What's the negative 2 do? What's the negative do? Flips over x-axis. So that's going to make it an upside down U. So the U's opening down. What's the 2 do? It's outside the house. So is that a vertical or horizontal stretch? Outside the house always deals with what? Vertical. Outside the house is always vertical. So it's a vertical stretch by what? Vertical stretch by 2. Okay? So it's a vertical stretch by 2. So let's go ahead and graph it. So I'm going to make a small little graph here, and I'll show you how to deal with the 2 because it's not 1-to-1 anymore. All right, what does the graph do? Tell me what happens. Shift it for me. How does it shift? Right 3. 1, 2, 3, up 1. Everybody okay with that? Which way does it open?
Down.
Down. Now, what's the vertical stretch? So usually you would go down 1, right 1, down 1, left 1, but you're going to do what? You're going to go down 2, right 1, down 2, left 1, just like the flying V from the last section. So we're going to go down 2. I'll do it in blue so you can see. 1, 2, right 1, and then you go down 2, left 1. So it's going to make it skinnier. You see it? All right, so let's go in order. So since A is less than 0, it opens which way? Opens down. What's the vertex? Talk yourself through it. It went right 3, up 1. So where's the vertex at? 3, 1. What's the domain? What's the domain for every one of these? Double bar R. What's the range? Now the range, be careful because we're going down forever. So how do you do it? Negative infinity up to what? 1. Bracket. And that's based on the y value for the vertex. Or you can go y is less than or equal to 1. Is that okay? You good? All right, x-intercepts. Here we go, zeros. Zeros, or x-intercepts. What do we let equal 0? We let y equal 0. So we're going to set the equation equal to 0. So we're going to take h of x and replace it with 0. So we're going to have 0 equals negative 2 times x minus 3 squared plus 1. Somebody talk me through it. What do we do first?
0 minus 3.
Yep. Minus the 1?
Oh.
I'm doing the x-intercept. We'll do the y-intercept in a minute. So negative 1 equals negative 2 times x minus 3 squared. What do we do now? Divide by negative 2. You got to divide by negative 2. So that's going to give me a positive 1/2 when I do that. X minus 3 squared. What do we do now? Square root both sides. All right, let's talk about square root of 1/2. It's going to be plus or minus root 1 over root 2. I am going to expect you to get rid of the root in the denominator here. All right, so I know it's a little bit of a pain. And I'm going to say something they might do in my open math. So I'm going to add 3 to both sides. So we're going to get x. We're going to get 3 plus or minus root 1/2. Let's talk about root 1/2. If you had trig, this would be pretty fresh. If you had trig last year, if you had pre-calc. First of all, what's the square root of 1? Please pay attention on this. What's the square root of 1? 1. So you have a 1 over a root 2. And I added 3 to both sides. Everybody see that? But you remember from geometry and pre-calc or trig, you can't leave a root in the denominator. So you multiply top and bottom by what? The same root. So you multiply the bottom by root 2 and the top by root 2. So you end up with 3 plus, so you end up with 3 plus, 3 plus or minus, what does it end up being? What's 1 times root 2? Root 2. And then on bottom, what's root 2 times root 2? What happens when you multiply a root by itself? It's the same root by itself. You end up with 2 2's, and when you have 2 2's, can a 2 come out? Yeah, anytime you multiply a root by itself, it cancels it. Root 2 times root 2 is just 2. Or you can think of it, if Keithan wants to do this, what's root 2 times root 2? It's root 4. What's the square root of 4? 2. But anytime you multiply a root by itself, it cancels. They're not going to require you to find a common denominator. But if they do, what would the common denominator be?
6.
What would the common denominator be? 2. So you'd have to multiply the first fraction, top and bottom, by 2. So you could actually get it all the way down to this. You could get it, and this is where you got the 6. You can get it to 6 plus or minus root 2 all over 2. They might do that in the textbook. They might find a common denominator, but it's not required in the My Open Math or on my test. Unless you do quadratic formula, it's not required to do the common denominator. You can just leave it as 3 plus or minus root 2 over 2. Okay, you are going to get roots for these. A lot of roots are going to show up. Y-intercept, what do you let equal 0? You let x equal 0. So you just plug 0 in. So you're going to have h of 0, I believe. They used h, correct? So we're going to have negative 2 times 0 minus 3. This one's easier. Most of you will not struggle with the y-intercept. What's 0 minus 3? What's negative 3 squared? What's 9 times negative 2? Negative 18 plus 1. Negative 17 is the y-intercept. There it is. So x-intercept, you set it equal to 0. Y-intercept, you plug in 0. Is that okay?
Hey, Morris.
Yeah.
What if we don't have school on Wednesday?
I'm going to have to Zoom y'all. We'll have to do a live Zoom. I can't afford to miss more minutes in this class. Okay. And I'll just do it at the exact same time. 9 o'clock. We'll just do 9 o'clock. 9 to 9:50-ish. All right. Any questions so far? Now, pretty much it's going to be the same thing when you go to general form, except we're going to have a different way to find the vertex. Okay, so what we just did was standard form, or what I like to call vertex form. Vertex form is when you can tell how it shifts left, right, up, or down, and then you get what's called the H and the K. Remember, inside the house, it's the opposite. So it would go right H or left H. If it's minus H, it goes to the right H. If it's plus H, it goes to the left H. And then K is the vertical shift up or down. Plus K goes up, minus K goes down. I don't really need to do that. Does everybody get the shifting?
Yeah.
Can everybody do left, right, up, and down?
Yeah.
All right. What's going to be tricky is the general form, and that's what I want to teach you now. The general form of a quadratic function is ax squared plus bx plus c. This is when it's actually FOILed out. And you've got your quadratic term, your x squared term. That's how we know it's a u. We've got our linear term. We've got our constant term. Now, you will prefer general form for some parts, but you're going to hate the vertex. Because the vertex, it's a little cranky, okay? Even though you got to crank that. Okay? All right? So the vertex form, that's what we just did. Vertex form, they call it standard form, but I call it vertex form. It's when you can tell the left, the right, the up, the down. A can't equal 0 because if A equaled 0, all this quadratic stuff would cancel out and you'd just be left with a constant. Okay, so that's not going to work. We talked about this. What page is this on? 190. We're on page 190. Okay. All right, so we've got x minus h, quantity squared, plus k, and then we've got the value of a. The parabola opens up if a is greater than 0. It opens down if it's less than 0. Is everybody okay with that? Yeah. Now, they're going to talk about, everybody already knew the parabola had symmetry. So everybody knows the left half is equal to the what? Right half. When you have this symmetry, there is what's called an axis of symmetry. This is actually going to help you for the next part, general form. Okay? By the way, how you doing? Pain okay? Pretty good. What? Okay? So x equals h, the vertex, the axis of symmetry. It's the dashed line that cuts the parabola into two equal parts. Okay? It's the dashed line that cuts the parabola into two equal parts. So there's a vertical line that cuts this parabola into two equal parts. Okay, two equal parts. So you have this left half that's equal to the right half. The left half is equal to the right half. Now, this is called the axis of symmetry, or what I call the AOS. Okay, AOS, the axis of symmetry. And it's going to go through the x value of your vertex. So whatever your vertex is, this x value is the AOS. Does that make sense? The x value of the vertex is the AOS. It's going to be that vertical line. So x equals h will be the vertical line that cuts the parabola into two equal halves. Now that's important when we go to the next part. So right here, x equals h. Okay? All right? So here's the parabola opening up. If a is greater than 0, it opens up. Notice x equals h goes through the vertex. X equals h is the AOS. Same thing over here. X equals h is the AOS. Okay, this is a parabola opening down, and that'd be if a is less than 0, a is greater than 0. I think we're kind of hitting this pretty hard. Is everybody getting this? Okay. Whoa. What page was I on? We'll do quadratic formula tomorrow. We'll save that for tomorrow. Where am I at? Okay, here we go. Now, to get to convert, this is going to be the hardest part of this section, by far, is if you want to convert a quadratic function from general form to standard form, we're going to have to remember something you haven't done since 9th grade. It's called completing the square. Okay? And it is kind of a pain. I'm just going to tell you. I'm just going to be upfront with you. You'll think this is the hardest part of this chapter. Okay? All right. What I've got is general form. It's multiplied out. I want to put it back in standard form, vertex form. But the problem is I don't have a house. I've got it. It's all multiplied out. I want to get it back to the house. I want to get back to like x plus h or x minus h squared. Okay, I want to get it back to this form. F of x is equal to a times x minus h squared plus k. That's my goal. So what we're going to do is we're going to complete the square. Completing the square is a process that takes a trinomial and puts it back into a perfect square. Now, a perfect square trinomial will factor into a binomial squared. Does everybody see that we have a binomial squared here? A perfect square trinomial will always factor into a binomial squared. Now, the problem is this doesn't factor into a perfect square. Watch. This factors, but what does it factor into? What does this factor into? It does not factor into a perfect square. Come on, factor this. I'm asking a basic step of factoring here. This is a trinomial. Can I find the factors of positive 3 that'll add up to give me negative 4? X minus 3, x minus 1. Don't write that down. That factors. But is that a perfect square? No. So I can't get it back into the form that I want. So what I'm going to do is I'm going to do a process called completing the square. That's going to get me back to a perfect square. So here's what you do. You ready? Here we go. I'm just going to do it right out of the gate. Complete the square. All right, if it's not a perfect square, and here's how you know. Your first term and your last term have to be perfect squares. If they're not, it's not a perfect square. Okay, your first and last term have to be perfect squares. They're not. So here's what you're going to do. It's this 3 that's the problem. Does everybody agree? Push it out of the way. Okay, push it out of the way. Here's what I'm going to do. The first one, this will be hard. The second one, you'll be like, okay, I got it. Okay, I got it. I've just got to practice this. Okay, I'm going to push the 3 out of the way. X squared minus 4x. I'm going to push the 3 out of the way. Push Keithan out of the way. All right. What you're doing is you're going to create a perfect square here. Something that will factor in the same thing twice. All right. I'm going to go on a limb and say you don't remember how to complete the square from 9th grade. But just to humor me, does anybody happen to remember how to complete the square from 9th grade?
Don't you add something?
You're going to add, well, we're going to add it to one side but in 9th grade we did add it to both sides. But we're using it for something else. All right, I call it half it square it. All right, I call it the half it, square it method. Everybody say half it, square it. Ready? Say it again with me. What are we doing? Half it, square it. What do we half? We're going to take half the coefficient of the linear term. Now, before I even complete the square, I need to say something. Okay, Keith, and I need to say something up front because you'll get mad at me if I don't say it right now. Before you complete the square, you need to make sure that a is equal to 1. If it's not, look up here, if a is not equal to 1, you need to factor it out. So if there's a 2 in front of the x squared, you need to factor it out of these two terms. You do not want to complete the square if a is not equal to 1. It will not work. Everybody, what has to equal 1? A. If there's something other here, you need to factor it out of these two terms. Okay? Because the next one, it's going to be like that. All right. So since a is equal to 1, we're good. We can complete the square. A must equal 1 to complete the square. If it doesn't equal 1, you got to factor it out. All right, here we go. Half it, square it. What am I halving? You're going to take half the coefficient of the linear term always. You use the linear term. Everybody use the linear term. So what is half of negative 4? So I'm going to go half of negative 4, and you will not write this down. You'll just do it in your head. It's too easy. You just half it, square it. It's not hard. So half of negative 4 is what, everybody? A negative 2, but it's actually not going to matter if it's positive or negative because what are we going to do to it anyways? So it's going to become positive no matter what. So it's a plus 4 that we want. Okay? So, college algebra, we're doing parabolas again. Half it, square it. So if I add 4 here, now ready, I'm going to perform a magic trick here. I'm going to add 4. I just changed the equation. What happened? Let's say I have $10 in this pocket and $10 in this pocket. You ready? I add $4 to this pocket. Which pocket has more in it right now? Before they were equal, right? 10 in each pocket, but I added 4 here. So if I add 4 here, I need to be able to keep it balanced. So in 9th grade, we added 4 to the other side. But I don't want you to work with the other side. So I need to perform a magic trick. I need to make that 4 disappear. So how can I make that 4 disappear? I'm on minus 4 at the end. Boom, gone. It's gone. Little sleight of hand, Keithan. Keithan's annoyed right now. Brody would be saying this is crazy shiesty math. He'd be like, what? You can't just do that. Wait a second here. Is that a plus 4 and a minus 4? Isn't that the same thing as what? So did I really even do anything? No, I just performed magic. I made that 4 disappear. Now, we're not actually going to cancel because I'm going to keep that plus 4 with this, and I'm going to factor it. What does x squared minus 4x plus 4 factor into? Negative 2 and negative 2, which is x minus 2. X minus 2, is that a perfect square? That's a perfect square. We're going to have x minus 2 times x minus 2, which you're going to skip this step, and you're just going to write x minus 2 what? Now we have our house. Can we tell if it's shifting left to right? Can you tell if it's shifting left to right, up or down?
Right.
It's going right too. And then at the end, we'll have the part that's going to tell me if it goes up or down. What is it going to be at the end? So, do we have our equation in vertex form now? Or what this college algebra book calls standard form? We do all the parabolas in one section.
I love completing the square.
I do too. Because you form, does everybody know what we form for Mr. Knutson? What do we form with it? We have an x squared.
Soldier boy, tough. Hey, I got this new damn.
Every time we cue it up. Okay? So we form a U-shaped curve. So this parabola goes what, everybody? Right 2, and then what? Down 1. All right, let's write all our information. So opens up or down? Opens up. Why?
Because there's no negative on those.
I know you're coming over here to brag about Duke.
I'm not, actually. I was going to see, should I move that sequence unit in front of the log unit
I'm going to.
for the pre-calc?
Yeah, just because it's on the
MSA.
MSA.
Algebra 3B class?
I would. Yeah, because it's on the 8. Yep.
All right.
All right. This goes right 2 down.
Duke is the bomb.
I know. Houston, go Houston. 2 negative 1. 2 negative 1. Their average player on the Houston Top 15 players for Houston basketball team average 5:19 in the mile for their mile time trial. They're the toughest team in the NCAA. Their fastest guy ran a 5:07. Their 6'9", 193 pound, 230 pound guy ran a 5:45.
See Morris, I could
Just
dig and
he
still run
he
fast.
put his my time trial on Twitter. Says we're the toughest team in the NCAA tournament.
My brackets.
Houston, they're in the Final Four. All right. Because they say the better condition you are, the better your basketball IQ goes up. So he says we're going to be the toughest team in the NCAA. So he did mile time trials all fall. All right. So 2, -1. Now we can do our domain. What's the domain? Double bar R. What's the range? Yeah, because it'll open up -1 to infinity or y greater than or equal to -1. If you graph this, I'll graph one more. I'm not going to do the x and y intercept right now because we did that. We'll practice again tomorrow with the x and y intercept because we're running out of time. So this goes right to down what? Down 1? And which way does it open? Up. What's the stretch factor? It's 1 to 1 again. So it's just up 1, right 1. So it'll just be up 1, right 1, and up 1, left 1. Draw your Oh, you could tell the x-intercept easy on this one, couldn't you? Yeah. You could do the x-intercept really easy on this one because it's just going to be 1 and 3. So this one you wouldn't even have to do any work on. The y-intercept the y-intercept you could do actually from the original equation. What's the y-intercept going to be? 0, 3, because you have the original equation. So you could do the x and y-intercept really easy on this one. Okay, tomorrow I'll come back in, I'll warm up with B, and then we'll finish the rest of the quadratics.
Let's go.
Okay?